Hi folks, it's Doug here from Mesh. Thank you very much for offering to stress test this little embodied carbon calculator for us. As a reminder, this is a conceptual stage 1 embodied carbon little free calculator that we're going to be giving out to help you guys along, speed up that design process at the start if you're interested in getting feedback on embodied carbon in your designs. I'm going to just spend 4 or 5 minutes taking you through the spreadsheet just by way of an introduction to help you get to grips with what we're doing here and just talk you through the main functionality. This first page on this calculator walks you through the simple steps, gives you some tips about how accurate we think this is. And do bear in mind this is an estimation tool, in no way a kind of a professional bit of software, but we're pretty sure that it's pretty accurate, and certainly for stage 1 it's fantastic. So it takes you through the various steps of what you need to do, and I'll walk you through this. So selecting material, building up your thermal elements of the building, and make sure you put in material thicknesses, put in your element areas, select the amount of doors that you're putting in heating, hot water and solar ventilation technologies, and then you can view at the end the relative embodied carbon in those key elements of the building, as well as benchmark against the 2030 RIBA targets. The key thing to remember here is, as we'll see on the next slide, is colour means something. So yellow is for cells that you put information into or selections that you make, and blue is the important output information for you. And remember, any calculator is only as good as the information that you put in. So let's get going. I'll just spend a few minutes explaining what we're doing here. So the calculator, generally speaking, is split out. You can look at 3 parallel building designs here. So you can drop in different materials and compare different building types, building concepts. We've got main elements like roof, walls, external, internal, doors, floors, foundations, other structural elements that you might want to put in, everything that might go into a building. And then, you know, selections that you can make here about electricity generation, heating or hot water, emitter, ventilation. And then a few other bits and pieces in here about kind of miscellaneous bits which make it a more realistic calculation. And the reason we have this bit at the bottom is to help you benchmark against the RIBA targets. So these will light up and it will tell you where your design is. This summation here where my cursor is the total embodied carbon. It will benchmark it against that to help you visualize that. And then you'll magically see bars appear here so you can tell the relative embodied carbon in the different parts of the building. So generally speaking, you build up the thermal elements based on the types of materials you've got in that element. You put in thicknesses because embodied carbon is all about volumetric. That's the metric that's using volume. And so if we've got thicknesses and areas, we can work those numbers out. So you put in what the thickness is of the materials that you're using, the areas over which that covers. We actually give you a pretty decent idea of what the U-value is going to be, because the bulk of this information is what you use to make a U-value calculation. And then it tells you what your embodied carbon is per square meter, and this is really important. So these numbers will only appear when down here you put in your floor areas. So once you've got these numbers in these 2 cells, everything in column L will light up. So we can start down here. You can start anywhere you like in this calculator. It will just build and build and build. So if we start with the floor, for example, maybe your floor area on the ground floor, I'm looking at gross external floor area at the minute. Let's say, for argument's sake, it's 100 square meters, and your internal floor area, and what I mean by that is intermediate floors rather than the ground floor. Maybe that's net internal area, because your walls are going to be making up you know, volumes of other materials. So you shrink down those intermediate floors, and maybe for argument's sake, that's 90 square meters. So you put those numbers in and start building up your floors. And I'm just going to throw anything at this. So let's say, for example, say you've got EPS insulation, and we're building this up, and maybe you've been really generous and you've put in, you know, 0.3 of a meter of EPS insulation. let's say, for example, then you have concrete, good old-fashioned concrete on the top of that, and say that's 0.1 meters thick. And these values that you're putting in are per meter, not millimeters, they're meters. If, for example, and this is a really good example, maybe you had a rebar in the concrete. If you go down to the bottom here, we've got this kind of others section down here, so other structures and reinforcement. You can, for example, if you know how much rebar you would be putting in there, you could choose steel, either recycled or virgin. And this is a volumetric, as these notes remind you, this is a volumetric input. So let's say, for argument's sake, there's 0.2 of a cubic meter of steel that goes in by way of rebar into your base. You can add that in at the end. And you build up your other floors. So maybe, I don't know, maybe you've got a timber floor here, which has got some joists in it. Maybe it's got, maybe you have some softwood plywood in there. And that plywood, I don't know, maybe it's 18 millimeters thick. You've got some joists in there, which, for example, may be 0.1 meters thick, and maybe you have got let's have a look at, so you've got some glass fiber in there as well. What is interesting to note here is, if I just change this to 0.1, if you have joists, for example, with insulation in between, their total thickness is 0.1. And because it's multiplied by this area, you have to make an adjustment. So maybe you've got joist, a whole load of insulation, another joist. The total of those two should equal 0.1. So let's say, for example, the wood is making up as a fraction 20% of that, or just over 20%, and your wood is making up the remaining 80%. 0.08 and 0.02 is making up your 0.1 of a floor thickness. And maybe, I don't know, for argument's sake, maybe there's some acoustic insulation in there as well, which is 0.1 of a meter thick. You know, whatever the numbers are, you can juggle these. You can put in information here about foundations, for example. In this particular case, we've kind of got a concrete raft here, so you would leave that out. Doors, external and internal. Doors are such a fractional contribution. We haven't gone into detail here. How many external doors have we got? Probably 2. How many internal doors? Maybe we've got 10 internal doors. And you can fill in the walls, external and internal. Your U values will magically appear. Your embodied carbon per square meter will appear. And the other really critical one is glazing. We've just gone for double or triple glazing. Just pick one of those. This isn't about getting lost in the mega detail here. This is just about giving you a really good indication. We've already made some selections down at the bottom here, but you can choose from PV or not. And if you're putting in solar PV, how many square meters, for example? Maybe you're putting 10 square meters on your roof. Maybe you're putting more, maybe you're putting less. To give you an idea, 20 square meters is 4 kilowatt peak of PV. And normally where a domestic house kind of tops out. You can choose from ground source heat pumps, air source heat pumps, gas boilers. You can choose from underfloor heating or radiators. You can choose to have mechanical ventilation and heat recovery, or just mechanical ventilation only. And when all this is done, it comes up with a magic number here at the bottom. So it's given 211 kilograms of CO2 per square meter. And in this particular case, because we've gone light and we haven't put in the walls, you're well in the RIBA 2030 standard here. And as you can see a summary of how much carbon's in the vertical structures, the horizontal structures, and other structures, but also as well as the energy in the building technology is also. Do also remember that you can't leave the building technologies out, because you've got operational energy as part of RIBA 2030 also. So have a play with this. Of course, you can mirror some of these things into your other building designs and start comparing like for like building designs using different materials. Have a play around. Please give us your feedback. Hopefully you find this useful. And of course, we're really interested in what you guys think. So thanks very much indeed, and look forward to talking to you more about this.